Okay, good afternoon everyone. I will start today's lesson. Today I'll discuss about the next two state of art pressure, lateral art pressure conditions. Those are active art pressure and passive art pressure. In the previous class, we have discussed about art pressure at rest condition. And if you have any doubts on that, you may speak up. If you have any query, any doubts, any question, then you may ask. Otherwise, I will proceed to the next part or next art pressure conditions. Those are active art pressure and passive art pressure. Okay, I'm sharing the screen. I think now you can see the presentation now. Okay, in the last class, we have discussed about the art pressure at rest condition, and in that we have derived one equation for art pressure at rest condition, that is P0 or P naught equals to K naught gamma H, and we have derived the equation for K naught also. K naught is nothing but the coefficient of art pressure at rest condition, as this is the vertical pressure due to the weight of the soil, weight of the backfill soil, that is gamma multiplied by H. This pressure is due to the weight of the backfill soil, and this is lateral arc pressure, and this lateral arc pressure is nothing but some portion of this vertical pressure gamma H, and that portion is K naught. So K naught is equals to mu by 1 by mu, where mu is the Poisson's ratio, and we have derived the equation for K naught or K0, that is coefficient of earth pressure at rest condition. Now the next part or next class of earth pressure is earth pressure at active condition, and third one is earth pressure at passive condition. Now to understand these two types of earth pressure conditions, that is active and passive condition, we have to first understand the plastic equilibrium condition. Now in the previous part, that's earth pressure at rest condition, we have discussed these equations, or we have discussed that this condition is dependent upon the equilibrium condition or elastic condition of the soil. That means the returning structure, that means this one, this returning wall or this soil is at rest condition, that means in elastic condition and elastic equilibrium condition. Now as there is no movement, we consider this condition as equilibrium condition, and as the total thing is in the limit of elasticity, that means this at rest condition is in elastic equilibrium condition. Now in the next part, that is active and passive condition, obviously the weight or the pressure due to the weight of the soil is increasing, and that's why the lateral pressure will also increase, and that's why the retaining structure or the retaining wall and the soil, or the backfill soil will move. Now the direction of the movement actually predicts the state or the condition of the earth pressure. That means if if I think you can see the picture, if this returning structure is moving towards this direction, that is due to this earth pressure towards this direction away from the backfill. This is the backfill. If the retaining wall is moving away from the backfill, tends to move away from the backfill, then that pressure condition is active condition, or the pressure is called active earth pressure. And if the retaining wall is moving towards this direction, towards this direction, towards backfill, then obviously the the pressure condition is called passive condition, or the passive earth pressure. That pressure is called passive earth pressure. Now coming to this section, that is these kind of condition these kind of conditions are called actually plastic equilibrium. At rest condition is in elastic equilibrium condition. We have used this equation, that is stress, the relationship between stress and strain and Poisson ratio and all those things are in between elastic condition, and that condition is in equilibrium. That's why elastic equilibrium condition. But the active and passive conditions are in plastic equilibrium condition. Now, what is plastic equilibrium condition? I think you have the idea about plastic condition. That is, plastic condition is nothing but when this movement of the wall due to this pressure, the movement of the wall is due to this pressure, and obviously this is proportional to each other. That is, if the pressure increases, obviously the movement is increases, and this is the plastic condition. But when this pressure alters, that is when this pressure is taken out, then the movement cannot be altered, or cannot be the movement cannot be zero when this pressure is zero, but this movement will not alters or go to the zero condition. That is, the this pressure and this movement is proportional up to some limit, and that limit is elastic limit. After that, elastic limit, the condition will be plastic. That is, in that case also, this movement is dependent on this pressure, and obviously that is proportional. But when this pressure is taken out, or when the pressure is uh, taken to zero, then this movement will not come to zero, or not come to the initial stage, initial condition. That condition is actually plastic condition. And the equilibrium condition is nothing but when there is no force acting on any system. No resultant force is acting any system. No resultant force. Obviously, there is force. There is force from any other side of maybe, but the resultant force is zero. Then only the system is in equilibrium condition. That means when the this wall or this wall, it tends to move towards this direction, but beyond the elastic condition or beyond the proportionality condition, then this condition is called plastic equilibrium. But please remember that tends to move, that means there is no movement, but the wall or the soil is on the verge of the movement. That means the soil or the wall is tending to move but not moving yet, but in condition of plastic condition. That means beyond the elastic limit. This condition is actually called plastic equilibrium condition of backfill soil. Now, obviously, when the state of at rest condition is exceeded, then this plastic equilibrium condition is coming to the picture. And obviously this plastic equilibrium condition means that the this movement of the wall. I think this is another picture, similar picture, but only one difference, that is this movement. This dashed line is representing the movement of the retaining wall away from this backfill. This is the picture for active condition, and if this movement or this deformation of this retaining wall or this soil after the elastic condition or elastic limit, then obviously this portion of soil tends to stretch. Stretch means obviously if the wall is moving towards this direction, then this portion will empty, or this portion will have the capacity to take this part of soil. That means this part of soil is having a condition to increase its volume, because this space, there is space up to this back of the retaining wall. This is the back surface of the retaining wall. But as this wall is moving towards this portion will be emptied, and obviously this soil is having more space, and this more space means more volume, and obviously this more volume tends to stretch the soil. These kinds of stretching condition tends to be stretching condition is actually the plastic equilibrium condition of this backfill soil. And as this wall is tends to move, that means uh, maybe you can consider that there is a slight movement of this wall, or there is a slight gap between this back original back surface and new back surface position. There is a slight gap, but after creating this gap, or after creating this slight movement, this wall will coming to at rest condition again. And obviously due to this pressure, due to this earth pressure, and that earth pressure is coming due to the vertical weight of the soil, then this movement of the backfill actually decreases and zero coming to zero coming starting from this portion, this position to this position, there is a gap, and after that this will coming to at end of movement. But at that position also there will be this vertical pressure. This value of this vertical pressure will constant, and that is gamma h, nothing but gamma h. Gamma h is constant, but after some time, after a slight gap of time, obviously this retaining wall will come to a static condition, not there is no movement at that time. After some time, due to this pressure, this movement is occurring, and after a moment, after some moment, this wall is coming to at static condition. If the static condition is not coming, then obviously the wall will collapse, and that is not the actual or practical scenario. After a moment, this wall will come to a static condition, and that's why this pressure, this movement will come to zero. That means this lateral pressure or lateral pressure will come to zero. That means decreasing from this position to this position. Active earth pressure is decreasing from this position to this position of the uh, retaining wall, but the vertical pressure, that is gamma H, will remain constant throughout this operation. That means if you remember the uh, condition of principal stresses or triaxial stresses, that is in the previous class also we have discussed about one triaxial stress condition or triaxial stress state. That means if this sigma 1 is considered as lateral pressure or lateral pressure, and this sigma 2 is the vertical pressure, this sigma 2 is the vertical pressure, that is gamma h, then this sigma 1 is decreasing up to some position of the retaining wall, but this sigma 2, that is gamma h, is constant. And uh, if we can remember the principal stress conditions in the uh, shear strength of soil, then you may understand that there is a, okay, I can show the equation we have discussed in some of the previous classes. What is that? Yes, yes, this one. In the, I think in some of the classes we have discussed about this equation, that is sigma 1 is major principal stress, sigma 3 is minor principal stress. As here, this sigma 1 is actually sigma 2, that is vertical stress, and sigma 1 is sigma 3, that is minor principal stress. As sigma 1 or the lateral pressure is decreasing, that's why we are considering this sigma 1 as minor principal stress, and this sigma 2 is as considered as major principal stress. And the sigma 2 is nothing but gamma h, sigma 1 and sigma 3 may be, as this is the triaxial stress condition, then sigma 1 and sigma 3 will be there, but in same value, because this sigma 3 is also a lateral pressure and this sigma 1 is the same lateral pressure, but this is in this direction, this lateral direction, and this one is this lateral direction. That means if you consider this is x-axis, this may be y-axis, but both the sigma 1 and sigma 3 has lateral pressure, and that's why I have written here sigma 1 equals to sigma 3, and this is actually PA, small p suffix A. This is the lateral pressure in active state, or you may say that say this pressure is active pressure. Active pressure or lateral pressure in active condition, or maybe active earth pressure, concisely active earth pressure. This PA you have to derive an equation for this PA, likewise the equation for P0. And obviously, as the movement of the retaining wall is due to vertical pressure, I have already told that it is considered as major principal stress, and I can write this thing also, that as PA, or maybe you may say this is sigma 1. Sigma 1 is decreasing. This statement is very much important. Decreasing, we are considering these as minor principal stress, and by this equation, okay, by this equation Okay, I'm coming to the previous presentation. That equation, you may write that sigma 2 is sigma 1 n phi, sorry, plus 2c root over of n phi. I think you are familiar with this equation. In the primary equation, this one is sigma 1 and this one is sigma 3, but the meaning of things are similar. That is, sigma 2 is major principal stress and sigma 1 is minor principal stress here, and by that we may derive an equation for sigma 1, and that is sigma 1 equals to sigma 2 sorry becomes sigma 2 minus 2c root over of n phi divided by n phi. Now here, if you forget the notations, that is, C is the unit cohesion or cohesive force per unit area. This C is the shear, one of the shear parameter, and n phi is nothing but n phi is nothing but tan square, sorry, tan square 45 degree plus 5 by 2. And this phi is the another shear parameter of soil. This C and this phi are the two most important parameters for shear strength of soil, and this is the equation for N phi. And now this sigma 1 is nothing but PA, or active work pressure, active lateral pressure. You may replace sigma 1 as PA. You can replace sigma 1 by PA. P is in small and A is in capital. PA equals to sigma 2 is gamma into H, that is vertical pressure or vertical arc pressure, that is gamma into capital H. H is the height of the wall, gamma is the unit weight of the soil, divided by, there is one term of N phi minus, then 2C 2C divided by, one part of root over n phi will be eliminated, and this will be root over of n phi. This is the basic equation for PA, or active arc pressure, that is gamma H divided by n phi, and minus 2C divided by root over of n phi. This is the basic equation for active arc pressure. And next, we are deriving the equation. We have to simplify this part, this n phi part, that is tan square 45 degree plus 5 by 2. We have to simplify or modify this part, and if you want to simplify this, this is equals to, now we have to recapitulate some equation of trigonometry, that is tan 45 degree plus 5 by 2, that is nothing but tan 45 degree plus tan 5 by 2 divided by, sorry, this is not minus, this is plus, tan 45 degree plus tan 5 by 2 divided by 1 minus tan 45 degree tan 5 by 2. This is nothing but the equation of tan a plus b, that is tan a plus tan b divided by 1 minus tan a tan b, and there is a square. We have to put the square here. Yes, anyone want to say something? No. Okay. Now, now you have to put the values of tan 45 degree, that is tan 45 degree equals to 1, this tan 45 degree is equals to 1. Now there is a square, or you may modify this equation as that is cos 5 by 2 plus sin 5 by 2, that is 1 plus tan 5 by 2 equals to cos 5 by 2 plus sin 5 by 2 divided by cos 5 by 2, and in the denominator here also cos 5 by 2 minus sin 5 by 2, and both in the numerator and denominator there will be 1 cos 5 by 2 in denominator, that will be eliminated. From that, the most simplified form is cos square 5 by 2 plus sin square 5 by 2 plus 2. cos pi by 2 sin pi by 2, and the denominator will be same with a change of sign only, that is this one will be minus. Now from this you can have cos square phi by 2 plus sin square phi by 2 equals to 1 plus sin phi divided by 1 minus sin phi, because these 2 cos phi by 2 sin phi by 2 equals to 2 sin phi, 2 sin 2 phi by 2, that is sin phi. 2 cos phi by 2 sin phi by 2 equals to sin 2 of phi by 2, that is sin phi. Okay, now this is the simplified form of n phi. This is nothing but n phi. Now this n phi is in denominator in each term of this equation, then you may put this one and this one. That will be like this. This multiplied by gamma h minus of 2c multiplied by root over of this one. This is the basic equation or modified equation for active lateral arc pressure, and this is for those type of soil which have C and phi both. That is, this equation is for C phi soil which have cohesion and internal friction angle both. But if you consider a soil with no cohesion, that is for cohesionless soil, for cohesionless soil obviously C equals to 0. sorry, small c, and in that case PA or active heart pressure equals to nothing but only this one. As C is 0, this part will be 0. This is for cohesionless soil. And if the soil is of cohesive nature, that is there is a term of C, there is a value of C, then the equation will be like this one. This is the primary equation of active earth pressure for cohesionless soil, and this is for cohesive soil or where there is some value of C. Okay, now this is actually this is the equation for lateral active earth pressure, that is P equals to Ka gamma H. Now this Ka is the coefficient of earth pressure at active condition, and this Ka, the equation for this Ka is equals to 1 minus sin phi divided by 1 plus sin phi, where phi is the angle of internal friction. This is all about active earth pressure, all about the basic equations for active earth pressure which you can use to determine or to calculate the active earth pressure due to this backfill soil with a height of h and unit weight of gamma. Up to this, is there any confusion, any doubt? Up to this, is there any confusion or any doubt? Please. Okay. This is up to active earth pressure, and I think I can stop the presentation now. About the passive case, passive condition, we can go for that in the next class. Okay, finally this one is the equation for active earth pressure. This one is the equation for active earth pressure. This one and this one is active earth pressure. And the coefficient of active earth pressure is actually Ka, and this part is actually the coefficient of active earth pressure, or coefficient for earth pressure at active condition. This one is the coefficient, that is 1 minus sin phi divided by 1 plus sin phi. Phi is the angle of internal friction. This is the most important characteristics of any soil sample. And if there is some cohesion, that is for cohesive soil, we have to use this equation where C and phi both are there. Okay, Okay, now anyone want to say anything? Now you can speak up. Yes.